I'd like to introduce our next speaker. He creates independent games using non-traditional interfaces. He attended the Recurse School and is still very active with other alumni. And he's an independent contractor, but has previously worked with MIT's Media Lab. And now he consults with early-stage startups to build MVPs and to improve development and design processes. Ladies and gentlemen, please welcome Mike Lazer Walker to the stage.
Hey, everybody. We good? Awesome. So, hey, everybody. I'm Mike. We're going to talk about some different stuff than a lot of the other talks you've heard today. You've been hearing a lot of talks about TypeScript as JavaScript that scales, and how do you help teams of thousands of developers write code. I'm going to talk to you about using JavaScript for a team of one developer. Your developer is also your designer and also your product manager and also your hardware engineer. And how the heck does that work, and why does TypeScript actually help you? Even weirder, we're going to talk about it in context of cross-platform games, where I'm probably talking about something different than you're thinking when I talk about either games or cross-platform. So I make weird installation games. The general pitch I give is they're all about taking the various systems that rule the world around us, whether they're social systems, political systems, environmental systems, and looking at how we can make them less opaque and more understandable using games and play and interactivity and non-traditional interfaces. So that can mean games played on the history of technology, like these are games played on a 1920s telephone switchboard and a 19th century telegraph hardware. This can mean board games. On the left, this is a game played using custom smart hardware tiles. On the right, this is a startup I worked with in Seattle to make the first tabletop games that use voice AI, like Alexa and Google Home. And most, if almost all of this stuff is using TypeScript and JavaScript and web tech. And I wanted to talk through the process that led me to my current workflow of making these sort of weird interactive physical experiences using this tool that's not really usually used for that. So these are all weird problem spaces that I'm dealing with. There are obviously interesting problems like how do you make 100-year-old hardware talk to a computer, or how do you design a game that's fun to play on a switchboard? But I think what's more interesting to me is one layer of abstraction higher. How do you design a process for even designing these sorts of experiences? So I'm used to working with early-stage startups and helping them figure out what should we be building and where are people going to get business value from our app. That's a process of experimentation, but that's a process where you talk to users and hear what they want, and you build something, and you see if it's what they wanted. On the software side, if you're dealing with a code base over time, you're used to trying out an abstraction, seeing if it's the right abstraction over time, and maybe it is or maybe it isn't. This is art, this isn't science. This is me saying, all right, here's a thing that I think works. I have a rough, vague aesthetic goal of what I want. If I build something, it's a very subjective measure to say, am I getting closer to or farther away from that? Which means in practice, I'm failing a lot. I'm throwing away most of the experiments that I'm doing, which is really difficult when there isn't really money in games like this. My resources are very limited. I've been very fortunate that like a lot of my work was funded by the MIT Media Lab. Sometimes I get arts grants. But for the most part, my resources are very slim and my time is very important. Which of course, this is why I make it very easy by working with hardware, which is, the people who are laughing are clearly the ones who have dealt with hardware. Forget compile times. If I have to run off a new circuit board, if I'm fabricating a circuit board myself, that could take a day. If I'm having it shipped out, that could take a week. So you put all this together, and I'm on a very, very tight constrained schedule where I need to fail as quickly as possible so I can actually make something viable. So this is a really, really weird set of constraints where I have the same problems that all of you do in terms of how am I balancing tech debt, how am I thinking about code quality now versus over time. But this is a very weird, hard set of constraints. So how did I end up using sort of web tech and having all the other problems? Let's talk through a couple different projects I've worked on to make this a little more concrete. So my main research when I was at MIT was all about location-based storytelling and looking at how can we use fiction to connect people to public spaces. This is an artist named Janet Cardiff. This is a piece called Her Long Black Hair, which is an audio walk she built in Central Park about 15 years ago. So you'd go to Central Park, she'd give you a Discman, and you'd wander through the park for 25 minutes. She'd tell you where to go and tell you stories, but it was also really all about this binaural audio soundscape. So as you walk around, you'd hear birds chirping, and you'd hear police sirens on 59th Street, and you'd hear a couple arguing behind you, and you wouldn't know, is that couple actually there, or are they part of this experience? And the way she managed to pull this off with static recorded audio is genius design. So for that specifically, she was using binaural positional audio that was set behind you, but that was static audio, so if you turn your head, they turn with you, and it completely breaks the illusion. But she uses all of the psychological priming, and again, genius design that I could talk for hours about to make sure that doesn't happen. And she had to solve similar problems with wayfinding and making sure that you were in the right place at the right time, things that you wouldn't have today if you're using a smartphone, but if this is a piece of recorded audio, you have. But the result was something that completely changes your experience and your relationship with that space. When I go to this corner of Central Park, this feels like a meaningfully different space to me than anywhere else in Central Park, and more so than places I've done museum audio tours or something history-based. The fact that it's fantasy and not reality matters. Pokemon Go sort of scratches at this, but it's not built for a specific space, so it doesn't have that sense of really connecting you to it. So I was interested in how can we bring this into the 20-teens? How can we take in everything that we've learned, the way that experiential theater is making interactive experiences in physical spaces, the way that independent video games and interactive fiction have done a lot of very complex work with how do you tell interactive branching stories. How can we use smartphone technology and the data sensors in your pocket to solve a lot of these design problems that Janet Cardiff had to solve so we can make building experiences like this more accessible to other people? So one of my first forays into this was a piece called Computational Flynn Era, built for the Come Out and Play Festival in San Francisco. So this is a site-specific generative poetry walk. So you go to this park in San Francisco, you download this app on your iPhone, it's free in the App Store, and as you walk around, a poetry robot makes up poems for you based on where you walk. So you walk by the cannons and you hear poems about war. You walk by the waterfront and you hear poems about the sea. And the artistic idea here is these poems aren't going to be that interesting. If you've seen any sort of neural net-based text generation, it's not that compelling as poetry. But the idea is it's interesting enough to pull you outside of your thoughts, but then not completely capture your attention. So it's akin to doodling. It's going to get you to engage with your environment more than if you were just walking around by yourself and getting lost in your own thoughts. I think it was a pretty successful artistic piece. As a technical endeavor, it was pretty frustrating. If you've done any work with GPS, you know the problem is having to test in an actual space is a real pain. And there are some things you absolutely have to test on site. There's no getting around it if you're trying to capture this aesthetic experience. But when it comes to actually figuring out, does this location code do what I want, that's really frustrating. And I built, so this was a native Swift app, and there was some tooling. I could drag a pin around in the iOS simulator and change my location. For what I was doing, building out GPX routes wasn't that useful. But that process was okay and kludgy. The real problem was this artistic problem of me trying to experiment with what data sensors are meaningful. How am I building up this procedural generation algorithm? I know I'm using GPS location. Am I using your GPS speed? Am I using the weather? What are the various inputs into this? And when I found myself prototyping these, I found myself wanting to be purely in creative mode and in this sandbox where I could play with toys, but I found myself having to dive down into programmer mode and write integrations for all these APIs as I was doing it, which pointed to this interesting thing that for this sort of rapidly prototyping these experiences, it's not just about minimizing the feedback loop. There's something subjective to the qualities of these loops, that if you have this sort of product stack, you want to keep those separate. Can I figure out, if I'm answering one question right now, am I answering a hardware or data sensor question? Am I answering a software question? Am I answering a design or art question? So when I came up to my next project, this was sort of a side project while I was doing this main research at MIT. As I mentioned, this is a game where you were a telephone switchboard operator. This is an actual physical switchboard from the 20s. We salvaged it from a paper mill in Ohio, and you're connecting people who want to make phone calls. It's sort of the classic time management style game where connecting a single call is very easy and actually works exactly like it would have on the hardware. You can read the instruction manual that came with the switchboard and know how to play the game. But it's very complicated when 10 people want to make calls at once and they're all very angry. And so I made a couple pieces like this that are all about how can we get you to interact with the history of technology by physically interacting with it and also by teaching you obsolete manual labor, because that's kind of fun. So this had all the exact same problems of the poetry walk, and that testing on this actual hardware is really frustrating. You want to abstract things out. But I also didn't have a choice. I absolutely had to build it in a way that I could test it without the hardware. So we started out with, this is a prototype I built, some machine-cut steel and some cheap plywood. once this got accepted to the Game Developers Conference Showcase in San Francisco, we went out and got the physical hardware. But it took about 2 months to ship this 200 pounds of vintage hardware to us. I had it for about 3 weeks, and then we shipped it off to GDC, at which point I had another 2 weeks to work on it. So with only 2 weeks to work on the hardware, sort of definitely a failure of project management, but what it means in practice is I need to be able to design a good working game without access to this darn hardware. And just to give you a taste for the actual flavor of what working with this hardware meant. So you can see this front panel, it pops up to reveal all these cables inside. You can see a little hole there where there used to be a lock. When we got it, there was a lock, and it was locked. And so we talked to the guy who sold us the switchboard. He had no idea. We went on eBay and bought a couple keys that might have fit, none of them fit. We got a couple people with lockpick sets, because there are a lot of those at MIT, and they tend to be very good, but none of them could get in. So I had to cut through a piece of sheet metal in the bottom. You can see it's empty there in the bottom. And we removed the lock, but then one of my colleagues said, oh, this is really, really simple. I can deal with this, and grabbed a set of calipers and opened his 3D modeling program. And long story short, here is the 3D printed metal key that we made that fits the 1927 lock, which is amazing. This is also many yaks to be shaving when I only have 3 weeks with the hardware. Which meant that everything needed to happen separate from this time, which meant I was thinking about what are the feedback loops I'm operating on, how am I actually building this thing? And at the base level, there's this question of how does this actual piece of code actually work? Does it do what I want it to? You are all professional programmers, you know what this looks like, you can write unit tests. Games in particular are weird, game engines are pretty testable. Game content is notoriously, like everything is still manual QA with pretty good reason. So I knew that I wanted to be able to sort of interact with it on a command line as a really nice way to, as I'm testing changes, if I can't easily test this, I can just go and interact with it like a piece of interactive fiction. I also knew, so it's easy to write code to see if code works. It's hard to write tests to see, is this game actually fun, which means you have to be playtesting. Even if I had access to the hardware, it's really, really difficult to make people come to you to playtest, to interact with this giant hardware. It's great if you can come to them. So I knew I wanted a version that you could use on like an iPad seemed like the right compromise. I can build you a nice touch UI to drag cables around, which seemed pretty important. Need to do that. And then finally, though, like I can use that to design a game that is fun and is mostly balanced. There's some work that needs to actually happen on the hardware, whether that is sort of difficulty tuning or onboarding is a great example of something where it's very different to tell people, here, you drag these around and this ugly gray box represents a cable. It's different to say, this is a giant piece of hardware that's really intimidating. Don't worry, you can play with it and use it and experiment, and it's not gonna hurt you. Which also meant that at any given time, you know, if I was lucky enough to have someone who was willing to playtest the hardware version, I needed to be able to run the current version of the code base no matter what state it was in, no matter what time I had last run it on the hardware, and have it work. So as a software problem, this seems fairly straightforward. You can probably already sort of imagine solutions to it. Games and hardware are pretty different than web tech. They're very, very performance-constrained areas, traditionally speaking. Like if you're dealing with microcontrollers, you're counting your memory for variables in kilobytes if you're lucky. In games, if you're doing traditional games, when you have a 3D engine and a physics engine, everything needs to be optimized to fit inside your update loops, so that update tick can be 16 milliseconds, so you can hit 60 frames per second. You're really focusing on sort of optimizing for computer time rather than developer time, which is directly in opposition to what I need to do. Fortunately, everything I'm doing is really, really simple, and computers are cheap these days. That switchboard game is a very simple state machine. It is not like I could have run it on an Arduino if I wanted to put that time in. All of the location-based storytelling stuff, not even coming close to pushing the limits of an old smartphone, even if I'm using a full 3D positional audio system. Like, I had a computer lying around for the switchboard. I could have used a $5 Raspberry Pi Zero, and that would have done the trick, which means I can apply all these great things that we're used to in web development, you know, good object-oriented design principles or functional patterns or however you want to write code. So long story short, this game is a pretty simple use of like the adapter pattern or however you want to call it. I can think of a half dozen different ways to describe this architecture where just here is a small self-contained game engine that when you create it, you're injecting in, here are some objects that you can call functions on to do things like turn on lights. And the game itself doesn't know or care what happens when you tell it to turn on a light. It doesn't care if you're actually turning on an LED or changing the color of a UI view or console logging something out to the console. Again, this is sort of probably very straightforward stuff to people used to doing this sort of software, but not the way that games or hardware games typically work. And it means that this is very easy to run this game anywhere that can run JavaScript. I can throw in that adapter for test or console log. I can throw out a version into JavaScript core in a native iOS app and have bindings to a Swift UI. I can have the version on the Mac Mini that runs a node that runs on the actual switchboard talking to some other processes communicating over serial. So we can have the separation that we need, which also has the nice benefit then of this meant that when other problems came up, having a relatively straightforward architecture meant it was easy to solve. So when we actually showed up to the conference, we had problems where this is more than anyone had ever used the hardware before. Turns out, software often breaks. Hardware breaks more than software. 100-year-old hardware is really not happy that often. So we ran into a lot of problems where the internal state of the game sitting in the Mac Mini, sitting inside the switchboard, did not match what was happening in the physical switchboard. Pretty hard to debug, really hard to do when people are lining up to play your game. But since we already had this concept of, all right, when we're at the start of the game, we're injecting in these input and output objects, we can make that an array. We can spend half an hour throwing together a WebSocket interface, so the already existing iPad interface can now show a live view of what's happening on the computer, and we can change things and make everything work. And this is something that wouldn't have been possible if I'd thrown this together a little more haphazardly, which is great. So this worked great for the switchboard. How does that come back to the storytelling stuff? How does this work when we're dealing with data sensors in the smartphone in your pocket rather than old hardware and Arduinos? What does it mean when I'm not trying to build a game, but sort of a tool to let other people build games? And sort of get concrete, sort of the end goal for the storytelling stuff was, here are site-specific radio plays where you go to a public space, here's an app on your phone, like in the Poetry Walk, and you're hearing a radio drama that is fiction that changes based on where you walk. And so you might be making choices that are literally, are you taking the left fork or the right fork? It could also be, here's the story you're only hearing if it's raining, or if you're there in the summer versus the winter, or weekend versus weekday, whatever we can get from sort of any network API or any sensor in your pocket. So this is a relatively well-defined problem space. Interactive fiction has been around for decades. Now there's a renaissance of people building tooling for interactive fiction for games. But interactive fiction in this context tends to mean here is some text on a screen, and you're going to read some text, and then you might pick a discrete choice from a series of choices, whether that is like a hyperlink in a web game or a 3D engine where you still have a dialogue list. That's not great, where the choices that you need to make here are things like the results of API calls or way fuzzier things. So I knew sort of existing tools weren't going to work. I needed essentially a narrative engine. The metaphor I went for was, if you're not using a monolithic game engine like Unity, you're probably piecemeal picking these bits and different pieces for your engine. Like if you're using Phaser, pretty common JavaScript game engine, it's using Pixie.js under the hood as its canvas rendering engine. It's using Box2D as its physics engine. Can we build this narrative engine that's a little small black box? You throw a story at it. You throw it, here is how you communicate to the game engine that it's being embedded in, and it handles managing your narrative state for you. We don't really have time to go into what it means to manage that narrative state and how sort of current state of the art is in terms of modeling interactive stories. But long story short, I built a thing. It's on GitHub. It's a couple different projects. So there's the engine itself, which is the small narrative core thing in TypeScript, where all of these concerns about wanting it to be cross-platform, so you can run it on your target platform like an iPhone or wherever else. That doesn't have to be JavaScript or TypeScript. That could be Swift. That could be C. That could be whatever you want. But knowing TypeScript and knowing the JavaScript ecosystem is really wonderful to be able to play on all this conceptual tooling that I already knew. The game itself is using sort of Flux architecture and those whole set of unidirectional data patterns, which means it's really easy that when sort of artists and authors using this tool want things like the sorts of debug tools they're used to having in other interactive fiction environments, like that looks a lot like Redux-style time travel debugging. So that's really, really easy to implement because I have this set of conceptual tools that work. And then sort of on the other layer, there is a custom scripting language that authors can use. So originally, this was just JSON. We're conceptually treating your story data as data rather than code. Going back to this point of wanting to be able to think in different modes, writers really don't like writing JSON. So here's a little scripting language built in JavaScript using OM, which is a lovely little language by the Y Combinator Research Lab, that sort of compiles down to this JSON. And you can see here the idea is sort of the third layer of this is the Swift app or whatever the app happens to be has ways to wire in data, and the authors can query on this data. Like here, there's this headphones variable and this proximity variable, which are tied into in the actual working version of the game. The proximity sensor on your iPhone and audio sensor is telling you if there are headphones plugged in. You can see a device variable being interpolated in a string that's going to return the name of the actual iPhone device, like an iPhone 10. And so this is sort of where TypeScript first started to make a lot of sense, and that as an API consumer, at the game engine level, you're passing in a string of a story. You're not passing in something that's already parsed. It's a single project. I'm treating them as two separate projects, and again, as the only person working on all of this, it would be weeks at a time where I'm working on one part of it and not touching the other. And with the switchboard, I often ran into problems where not touching one of these interfaces, things would break because I'd change that API contract because I'm moving so quickly by necessity, and there would be nothing to stop me and say, whoa, 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 you broke that contract. TypeScript was a really elegant way to solve that problem. And it turns out also when everything is JavaScript or TypeScript is in this ecosystem, you have the synergy where now the switchboard itself, the interactive tutorial is running this as well, and instead of tying into iOS APIs, it's tying into those exact same inputs and outputs from earlier of being able to turn on lights. But this sort of led to a really interesting, unexpected benefit of TypeScript. So if you think about the design of this language sort of as a user story, if you are a person writing a story for this, maybe you're a programmer, probably you're not. You're probably like a very smart person who knows how to think computationally and in these sort of scripting languages can communicate very complex things with the conditional system and such. But you don't want to have to think about like if there is a sensor that's being passed in data to you that's probably going to be like the number 2, is that going to be a string or is it going to be a number? If you're comparing things, what sorts of problems are there? Sort of on the technical side, you can imagine a more complex version of the scripting language compiler that ties into the TypeScript compiler and has types and does all this properly. But for now, for the version where I had to bang it together very quickly, this sounds a lot like the design of JavaScript, where JavaScript is built very, very quickly with an eye towards you have all these people who write HTML and CSS and may not be that comfortable writing scripting languages. How can we do things like this type coercion that maybe 20 or 30 years from now, more experienced developers are going to hate us for it, but it does a really great job for this audience. So by having this whole thing built on top of JavaScript, I was able to take advantage of those things and build something that suits that same audience, which was all great. I figured, great, I get this basically for free until I started integrating with Swift. And it turns out when wiring up sensors in Swift, I basically had to completely eject from the type system and cast everything to any. As opposed to in TypeScript, I was able to use union types. I was able to use all these other really nice aspects of the type system that were built for the nuances and specificities of JavaScript, which is really awesome. But also, it goes without saying, like that was a really nice aspect of TypeScript, but most of what I gained from it over the earlier projects just using vanilla JavaScript were this basic, here is someone that's going to catch all my bugs for me. Like I think we've heard a lot about earlier today, that things like writing tests are often wonderful, wonderful ways to catch bugs. They're slowing you down in the short term in order to speed you up in the long term. Whereas for my weird set of trade-offs, slowing me down in the short term is not acceptable. And TypeScript was this perfect tool that gave me a lot of forward momentum and let me know when I was breaking things, but didn't really slow me down, which was phenomenal. Of course, there's a really valid complaint about all of this, which is if you are one developer working on a project that is small enough that everything fits inside your head, does it really matter what you do? You can get away with a lot. I have seen a lot of projects that I would describe them as being very poorly written code, but they work. And there's sort of a completely orthogonal relationship between code that is not good as long as it is just good enough and building a good product or a good piece of art or whatever it is you are trying to do. And I don't know if I have a good answer to that, at least that in my case, I know that I have been more efficient using TypeScript than using JavaScript and more efficient using JavaScript than other technologies, even in the case of like Swift, where they're technologies that I already know. I think it's also really interesting, like when doing sort of teaching about creative coding and this sort of thing, I interact with a lot of experienced developers who get frustrated that a lot of this sort of education is focused on how can we bring people who aren't programmers into the fold, and how can we teach them tools like processing and all of these things that are really, really great programming tools. But if you're used to writing in a full programming environment and know something very well, you're going to get frustrated by the training wheels they're putting on you. So I think it's really great to be able to talk about and use all these tools that like everyone in this audience already uses as part of their day job. Which isn't to say that you need to go home from your day job and work on a new project in TypeScript. But if you want to artistically express yourself, having a tool that you already know really well reduces that barrier to entry in a really interesting way. Finally, I think there is something really great about being able to take all of this work of all these giant tech companies throwing resources at building open source tooling designs to make everyone more productive and deliver business value to the world and say, we don't necessarily need to keep delivering business value. We can take all of these exact same tools and co-opt them to make these weird experiences that help show people something different about the world and help reframe the way they view the world, which I think is really great and wonderful, and I'm glad is something that I can do. That's all I got. Thanks.